Alrighty, friends, we are going to wrap up what we're doing in chapter 11 by talking about how to collect data and ways that you can do that more effectively. We've been doing like data analysis with mean, median, mode, all that kind of stuff, but this is how do you actually collect the data. So let's talk about some vocabulary words that you need to be able to kind of understand. Population is going to be a group, typically of people, but it could be of objects. And I always think of this as like the whole thing, the whole population. So like the entire school would be a population. Everybody in Lakeville would be a population. But you can't ask everybody something and get a response. So we usually try to get some of the people. And so that's called a sample. It's called a subset, meaning a little group within the population. So it's a subset of the population. And it's like the people that you actually ask in a survey. And so this is going to be just like a part of the population that's involved in your data collection. So depending on how you collect your data, you can get a biased sample or unbiased. A biased sample is going to misrepresent the population. So for example, if you depending on who you ask about something, you can get a really biased answer. If you ask all the band kids whether they think, music programs should get cut, they're all going to say no because they're in band. So that's misrepresentation of the entire population where some people might think it should, which it shouldn't because band is amazing. Unbiased sample is going to be obviously the opposite, and that's going to be one that better represents the whole population. Without asking the whole population, you can't represent it perfectly, but it's a better, clearer representation. It's a little more fair. So these are methods, meaning ways that you can go about collecting your data. One of them is called self-selected. It's basically people that volunteer, and they agree to do whatever it is. You might send out a survey, and people will reply if they feel like it and not if they don't. So they agree to do whatever it is or not. For example, if you're walking around the mall and they're trying to get you to do a survey, if you stop and do the survey, you're self-selecting because you are volunteering when you did not have to. And that usually tends to be biased because people will answer if they have strong feelings about something. So if I send out a survey about seniors having to take final exams, I'm going to guess the seniors are all going to answer with their feelings on that because they want to have a voice in that. So they care about it a lot, and that creates sort of a bias in my collection. Systematic is exactly that. There's a system to how you collect the data, and so there's some kind of a rule that you set. So maybe you're going to stop every whatever you want it to be, 10th person. You're going to stop every 10th person, and that's going to be how you collect your data, or every other person, or whatever it's going to be. And that one's going to be a lot lesser unbiased because you don't know that every 10th person is going to feel the same way. A convenience sample is exactly that. It's convenient. It's easy to access. But people that are easy to access for you usually have a relationship with you. So if I'm going to use like contacts in my phone, or I'm supposed to be collecting data, but I kind of forgot, and so I just am going to do like kids in my class. So I'm just going like, again, let's say I'm in my Algebra 2 class and I have a survey about math. Well, everybody in there is going to kind of have an opinion that's similar because they're in my same math class. So that creates a bias too. Or you're sitting at your lunch table and you decide to ask your friends. Well, they're your friends because you guys have the same kind of thoughts and interests. So you would probably answer whatever the survey is in a biased fashion. Random is the only truly unbiased way. It's just tricky to do, but it creates a situation where everybody is equally likely to be chosen. So, I mean, it's truly like drawing the names out of a hat, or creating a situation where it's completely random. So the more random your sampling method is, the more accurate your results will be, less bias. So a sports writer wants to survey college baseball coaches about whether they think wooden bats should be mandatory throughout college baseball. Identify the type of sample described. Okay, and is it biased? A sports writer contacts only the coaches that he has in his cell phone to get a quick response. Okay, well, both getting a quick response and picking up your own phone and just contacting them means that this is convenience. So the method of getting that sample was convenience, which by nature is biased because he is a coach for baseball. So probably a lot of the people he has in his contacts are baseball people. So they'll have a biased opinion. How about if the sports writer mails out surveys to all the coaches and only the ones that are returned do they use? Okay, well, sending it out to everybody is a great idea, but again, only the people that want to answer and have probably like a strong feeling about it will answer. So they're going to be the volunteers or self-selected. Like they are deciding, oh, I want to answer this survey and taking the time to do it. And that one is going to also be biased because it means that only people who care enough are going to, get in there and do that survey. The sports writer contacts and surveys every fifth coach on the list of college baseball coaches. Well, that has a rule to it. So that's going to be systematic. And by being systematic, that will be far less biased. So it's going to be more of an unbiased sampling simply because it's a method. It's not going to select people that have the same feelings or thoughts. All right. You're a member of the prom committee and you want to poll members of the senior class to find out where they want to have the prom. There are 324 students in the senior class. Describe a way to pick 40. That is a convenience sample. I would say that you could here just ask seniors in your classes. So throughout your day, if you have some that are mixed seniors and juniors, and you ask the seniors that you run into, you are going to just ask them, which is going to create bias. Random, I guess you would just like have to draw names of 40 seniors, perhaps, off of a list of our seniors. That is going to be unbiased. That's the best way you can do it is random. It's just hard to find perfectly random ways. Systematic, you could do a rule. So you could do like every fifth person, like in alphabetical order until you have enough. And then that would be relatively unbiased because it's going to not contain the same types of people necessarily. Self-selected would be like if you mailed out like a Google form, or you sent out a Google form, and then they can return it if they want to. Now, the problem with that is going to be like a kid who's not going to go to prom is probably not going to answer because they don't care. So you're going to get a more biased sample because the people that respond are going to be people that have like strong feelings about where it should be and what it should be like. Okay, so let's talk about sample size. The bigger your sample size, meaning you asked more people, that will lead to better results. And by better results, it means that you will get closer to what everybody thinks. You can't like ask 2 people out of the senior class and then say like, oh, 2 people out of 2 people, 100% said the same thing. You need more than 2 people to properly represent and get better results. Now, margin of error is going to be something we calculate. And margin of error is going to be how far off the sample results are from the population, from the whole. So it kind of measures accuracy. So as you have a bigger margin of error, you have less accuracy. Now here is a formula for finding it where N is going to be the number of people that you have in your sample size. So this is a formula that you want to be able to know and use. So if you have a margin of error you're going to use plus or minus because you're saying, oh, like the results of the survey were that 80% of people want prom at, the same place. And then your margin of error is going to be like give or take 3%, perhaps. So it could be, instead of just being 80, it could be 3 higher than that or 3 lower than that. You're giving yourself like an interval or a buffer. So if 40% of the people in the poll preferred candidate A, the margin of error is 4%, then it is likely that blank of the entire population prefer candidate A. So if you have 40 in the middle as your result, but it could be 4 higher and it could be 4 lower, you're going to say, hey, it could be somewhere between 36 to 44. One is 4% lower and one is 4% higher than the survey results. Keep in mind that as the sample size, meaning the number of people you ask, goes up, so that's going to be n increasing, the margin of error will go down. So the more people you ask, the more accurate it's going to be. Your region of error, margin of error, is going to be lower. Okay, in a survey of 1,011 people, so that's N, 52% said that the television is their main source of news. What is the margin of error? Well, our formula up here says that margin of error is related to the number of people surveyed, which is going to be 1,011. Now this kicks out a decimal, and we have to be smart enough to say, hey, I'm going to write that as a percent. So I move that over 2 spots, and my margin of error is going to be plus or minus 3.15%. So whatever our percent was in the results, it could actually be 3.15 higher than that or 3.51 lower, which is what this next question is asking us to find. Give the interval that's likely contain the exact percent, because we didn't ask everybody. So it's somewhere around the 52% that they got, but our margin of error suggests that it could be 125, I can't read my own writing, 3.15 higher, or it could be 3.15% lower. So the actual interval, if you subtract and then add, would be like 48.85% on the low end and then when you add the 3.15 to the other end, you're going to be at 55.15%. So this is like the low end, and this would be the high end of your interval. So you're saying it's probably somewhere in between here. Is it perfectly 52 like they said? Probably not. So this last one is asking us to work backwards. It says a polling company conducted a poll for the U.S. presidential election. How many people? So it's asking you to find N. Did the company survey if the margin of error was plus or minus 5%? What I'm going to do is take my margin of error formula and I'm going to rearrange it. What happens then is I end up with N up here, number of people, and that will equal plus or minus 1 over my margin of error squared. But this has to be a decimal, not percent. So I would add this formula into your notes so that you are not, we have that one already, this formula into your notes, which is just a rearrangement of our margin of error formula, because this one is going to be the one that helps me find my margin of error, and this one helps me find how many people did I ask. So in this case, the number of people is going to be plus or minus 1 over, and our margin of error was 5%, but that's 5 out of 100. So you move that over 2 spots, and that decimal is the thing that goes in here. So if you do that, you should end up with N equaling plus, or I don't need a plus or minus here, because here I'm finding out the number of people, and that obviously isn't going to be a negative. So it's just saying, hey, how many people did you ask? And I would have asked, if you did this on your calculator, 400 people. So when you're trying to find how many people you asked, you're going to use this formula. And you don't need the plus or minus because you're just figuring out how many people it was. Here you need the plus or minus because you're going over or below that survey result and saying, oh, it could go up to this high or down to this low. So those are the two things that I would focus on as far as math, and the rest is just kind of vocabulary and understanding the different ways of collecting data. So hopefully that helps, guys. Bye.